All right, so we've already talked about graphing piecewise functions. So I'm gonna go back to those notes from day one. So that was on March 4th when we first did the graphing piecewise functions. And I'm gonna go back and take a look at the word problems and finish those and the step functions. So a step function is a piecewise function containing all horizontal pieces. So everything is horizontal. So the constant pieces are valid for distinct intervals of the function. They could change and so on and so forth. So we're looking at these. These are nice and simple. You don't really have to create a table if you want to because everything's horizontal. So this is everything less than -2 at 3. So I'm going to come down here. -2 is right here. If it helps to draw these. And then you got 1 as another boundary. So -3 is going to be everything less than 2. So I come down here to -3. I got an open circle. Boom. I got that piece. That's step. Then I come up here to the middle one. 0 is in between -2 and 1, and it's equal at both. So -2 and 1, and it's equal at both. And then at 1, it's 3. So I come up here, 1 go up to 3. It's open circle, and it's everything greater than. So the biggest thing here is just remembering the open circle and the closed circle, and then you can go through and erase your boundaries to make it look pretty. And when you're done, everything should be a horizontal line. That's what makes it a step function, so it actually looks like little steps. Cool. So they don't always have to go in order. Most of the time they do, but they don't always. So once again, my bounds are at 4, -2, 2, and 4. So -4, -2, +2, and +4. Just get my little boundary so it kind of splits it up into your different sections. So y is going to equal 4 between -4 and -2. So I come up here, so it's -4 is closed, 2 is open, and I draw the line. They're both open here between -2 and +2 at 2, so they're both open, we're coloring. And then my last one, -3, they're both closed here from 2 to 4 at -3. So 2, 4, both closed. And then let's go through and erase all of our orange lines just to make our graphs look prettier. Voila, you have your step function. If you want to go through, clean it up, make it look a little nicer so you know that's an open circle, that's an open circle. The rest look pretty good. The greens are both closed, so on and so forth. All right, that is your step function. All right, now taking a look at this, writing it piecewise, we already talked about that in graphing, so now we're going to look at a word problem scenario and application to go from there. So the post office offers a flat rate mailing packages. So the first one, it's $1.50 if the package weighs less than 4 ounces. It's $2.50 for a package weighing 4 to 8 ounces. And it's $3.50 for a package weighing 8 to 12. If it weighs more than 12, you are out of luck. So let's write an equation. So the first step, it's going to cost me $1.50 if the package is less than 4 ounces. So 0, if it's less than 4 ounces, well, I guess it can't really equal 0. But less than 4 is the big thing I'm looking at, so not equal to it. The next one is going to cost me $2.50. Oh, forgot my dot. If it's 4 ounces to less than 8 ounces, so 4. If it's 4, it's equal to or less than 8. So that's why the 8 is open and the 4 is closed. And the last one, it's $3.50 if it's weighing from 8 ounces to 12 ounces. So there's my step. I'm going to kind of zoom in here on the graph. You can jot it out. So it's $1.50. It's going to be kind of small here. Whoops. So it's $1.50 if it's less than 4 ounces. So here's 4, we're at $1.50. Less than. And then if it's from 4 to 8, it's 350. So close. And then this one was open. And then the orange one's gonna go from 8. It's $1.50, $2.50, and $3.50. So close. We'll make this at 12. That's roughly 12. And you got your graph here. Cool? So it's just taking it and just applying it. So you got both scenarios going to town here. Graph, there we go. We already did the evaluating and then checking for understanding. Classify all these statements as either always, sometimes, or never true. So we're looking at this first one. Are all piecewise functions considered step functions? They're not all step functions, but some are. So this is going to be sometimes true. Because you can, a step function, are all step functions considered piecewise functions? Yes. A step function is always a piecewise function, but a piecewise is not always a step. So, just taking a look at this, my heater AC or whatever came on. So look at your step functions, understand these are always just horizontal. We're gonna use these a lot in our word problems. So take this practice. I hope you have a wonderful rest of the day, and I will talk to you soon.